Welcome to Ask and Learn.
Okay, so in the first part, we are looking at no air resistance. So energy conservation will go as follows. You have your initial kinetic energy, 1/2 mv1 squared. You have your initial potential energy, mgy1, and you set that equal to final kinetic energy. And there's no potential energy and no work done by friction there. Okay, so the m's cancel. You're left with v2 is the square root of 2gy1 plus v1 squared. Now v1 is in a very unfortunate form. It's in kilometers per hour, so 480 kilometers per hour. You multiply that by 1/3600 to get so 1 hour per for 3600 seconds to get kilometers per second, and you multiply by 1,000 to get meters per kilometer to get meters per second. Okay, and so this comes out to be in meters per second 133.33. So that is our v1, and so let's go ahead and plug that in. You have 2 times square root of 2 times 9.8 meters per second squared times 3,500 meters, which is the height, plus 133.33 meters per second quantity squared. This gives us V2 of 293.8 meters per second. If you want to convert this to kilometers per hour, you multiply by 3,600 seconds per hour times, of course, 1/1000 kilometers per meter to get about 1,058 kilometers per hour. So much, much faster in the absence of air resistance as expected. In part B, we first start by figuring out what distance the friction force or force of air resistance would act through. And so essentially what you have is this. You have an angle 12 degree, and this is height, or 3,500 meters, and you're interested in the distance through which force friction acts. So d would just be, or d over h would be sine 12, implying that d, this distance is, whoops, I meant to say h over d would be sine 12, pardon me. And so d is h over sine 12, so it's 3,500 meters over sine 12, giving us 16,834 meters. Okay. Now we just do energy conservation. Initial energy is the same, 1/2 mv squared v1 squared plus mgy1. Final kinetic energy is still 1/2 mv2 squared. But add to that, we have a force of friction times distance, which we just found. Therefore, force of friction is just, let's take m common, m times 1/2 v1 squared plus gy1 minus 1/2 v2 squared over d. So let's just write it down like that, over d, right? And so, right, again, you have the unfortunate velocity 2v2 given in kilometers per hour. So 210 kilometers per second, kilometers per hour is that times 1/3600 equals 58.33 meters per second. Okay, now we have everything. We plug in mass, 980 kilograms, d, which is 16,834 meters, times v1 squared over 2, 133.33 meters per second, quantity squared over 2 minus 58.33 meters per second quantity squared over 2 plus 9.8 meters per second squared times 3,500 meters. Okay, and so all of this comes out to be, so the force of friction comes out to be 2,450 newtons. That's the end of the problem.